Hello everyone, my name is Billy Zhang, and I'm presenting my thesis exploring the potential of generative AI for secure querying. I will walk through the motivation, design, and expected impact of a system that leverages AI to simplify datasets querying for clinical research. This part is about motivation problem. Clinical research relies heavily on structured datasets, often in CSV and proprietary SAS7BAT formats, which store patient data. However, access insights from these files typically requires writing SQL query, a skill set most clinicians and research coordinators do not possess. Dependence on specialized data engineers not only creates a bottleneck, delaying critical findings, but also increases project costs and the risk of miscommunication. Additionally, clinical datasets frequently contain irregular schemas and must comply with regulations such like HIPAA, making traditional BI tools less suitable and further complicating data access from non-technical users. For the purpose of this design include three parts. The first is we aim to empower clinical researchers by providing a natural language interface where they can ask questions in plain, narrow English. Second, we automate the translation of those questions into valid SQL query, execute them against clinical datasets, and display the results seamlessly. The third part is we ensure that the entire process adheres to security and compliance standards, maintaining data integrity and confidentiality at every step. Overall, project goal, is to reduce time to insight, lower operation costs, and improve data-driven decision-making in clinical research. This slide is about conceptual framework. User-centered design. We have the interactive feedback with clinicians. For development, we choose Agile. 2 week will build a sprint, and we also use CI/CD for better compile and deployment. For the code design, we choose modular architecture. It will ingest users' query and pass to the backend for the query engine. The result will be returned to the UI. This part is about the system overview. We can see the front end we are using the React. The component we choose Material UI component library. The protocol we use Fast API backend. So the backend we also choose Python. We also have the database. We can see the second part, the major framework we choose LangChain because it provides a friendly integration with the other modules and also have a very good agent design. We will choose the SQL agent. The end part is the database. It will read and analyze data from database. The last part is about the result. The result will be returned to the UI, to client directly. We can see the result from the datasets. This part is about key innovation. This is a new project built from ground up. Our system introduced three main motivations. First, we fine-tune the large language model on clinical data. The second part is about automated schema interface from a messy CSV SAS7BAT. For our system, if we upload a CSV file or SAS7BAT data to our system, the system will analyze the data structure, build the schema on the database. This meta information will be used for the following SQL query and analysis. The third part is about interactive interactive UI. This UI will provide very clear, user-friendly feedback. We can highlight the errors, suggesting schema corrections, and guiding users towards successful queries, thereby reducing frustration and training needs. For the requirement and the hypothesis, we define comprehensive requirements covering functionality, performance, and security. We also introduced a natural language parsing and multiple format ingestion, like CSV and 7BAT, and error handling, generation, and non-functional requirements. For the hypothesis, natural language users will complete query task at least 50% faster than the traditional SQL users. Like we need to read the data, understand the relationship, and create a SQL query. For H2, automated schema interface will achieve a minimum of 90% accuracy in mapping columns and relationships, reducing query errors by at least 30% compared to manual efforts. This part is about security compliance. Our system employs role-based access control through OAuth 2 and GW2 to ensure only authorized users can submit queries. All generated SQL pass through an ORM layer for sanitization. Data at rest is encrypted with AES-256, and all communication is secured with TLS. Additionally, we maintain detailed audit logs for every query and access event, providing traceability from compliance audits and support HIPAA and other requirements. The next slide is about the next steps and the roadmap. Looking ahead, we will conduct additional user testing rounds to refine AI prompts and UI workflows. We plan to integrate live EHR data feeds to expand the real-time querying capabilities. We also prepare a pilot deployment in collaboration with clinical partner institutions, gathering real-world usage metrics to guide further improvements and support scale-up to production environments. This is our next steps. Yeah, thank you. Thank you for your time and attention. I hope this overview has provided clear insight into how generative AI can transform skill query workflows in clinical research. Thank you so much.